All right, you're going to want to hear this. A brand new paper just came out of Meta's Superintelligence Labs, and it's a big one. It tackles one of the most frustrating bottlenecks in AI right now, raw speed. They've come up with a trick called REFRAG, and it's promising an absolutely insane 30 times performance boost. So let's break down how on earth they pulled that off.
So here's the core paradox, right? We want our AIs to be incredibly knowledgeable. We want to be able to hand them a giant pile of documents and have them understand it all. But the more information we give them, the slower and more clunky they get. It's like we're making them smarter but forcing them to run through mud. How do we get the knowledge without the slowdown? Well, the standard way we do this today is with a technique called Retrieval-Augmented Generation, or RAG for short. The best way to think about it is like a brilliant researcher. When you ask it a really tough question, it doesn't just pull an answer out of thin air. No. It goes to its digital library, finds the most relevant books and articles, reads them, and then it gives you a smart, fact-based answer. It's an amazing technique for accuracy.
But, and this is a big but, here's where we hit a wall. If that AI researcher only needs to flip through a few pages, what we call a short context, everything is snappy and fast. But if we give it a whole library shelf of books to read, a long context, the whole system just grinds to a halt. We're talking a massive drain on computing power and memory. It's a huge problem.
And the authors of this new paper, REFRAG, they nail it with this quote. They call it a fundamental trade-off between knowledge enrichment and system efficiency. For a long time, it's felt like you had to choose. Do you want a really knowledgeable AI or do you want a fast AI? You couldn't have both.
So what's the actual culprit? Why does it slow down so much? Well, the secret is a massive hidden inefficiency in how the AI pays attention.
See, here's what's so interesting. When our AI researcher goes to the library and pulls, say, 10 books off the shelf, it turns out that most of the pages in those books, they're not actually useful for answering your specific question. There's maybe a golden nugget of information here and there, but the rest is just noise.
And this is the absolute key. The AI's attention mechanism as it exists today is kind of dumb. It's a brute force tool. It feels obligated to read every single word, even all the useless, irrelevant ones. Can you imagine forcing a human researcher to read a 500-page book from cover to cover just to find one important sentence? It's a colossal waste of energy and time.
So this was the light bulb moment for the Meta researchers. They saw this pattern and called it sparse attention, meaning the AI is only really focusing its useful attention on a few tiny, sparse spots, while all the computation spent on the rest is completely wasted. Identifying that waste was the first step to solving it. So, armed with this huge insight, they built a really clever solution to stop the AI from wasting all that effort, and they called it REFRAG.
REFRAG stands for Representation for RAG, and it totally flips the script. Instead of handing our researcher a stack of thick books, REFRAG pre-processes them into super compressed summaries. They call them chunk embeddings. You can just think of them as little digital index cards. So now the AI gets a neat little stack of summaries instead of a whole library.
And this one simple idea has these three huge advantages. First, obviously, it makes the input that the AI has to read way shorter. Second, you can pre-compute these summaries ahead of time and just reuse them, which saves a ton of time. And third, and this is the most important one, it just massively cuts down the work for that attention mechanism, which, remember, was our main bottleneck.
The whole process is actually this really elegant three-step dance. It's all about compress, sense, and expand.
Okay, so here's how it works. First, the system compresses almost all of the documents into those compact summaries, those chunk embeddings. Then a second, really lightweight AI acts like a super fast assistant. It senses which of those little summaries seem most important for the question. Finally, only those few absolutely critical chunks get expanded back into their full text for the main AI to read carefully. It's a brilliant filtering system.
So here's kind of a blueprint of the architecture. You've got this lightweight encoder model that's doing all the smart compression work up front. It then feeds this mix of compressed summaries and a few key full-text documents to the main, big AI model. This setup lets the big model focus only on what matters, which lets it work so much faster. All right, so the theory is beautiful, right? But does it actually work in the real world? This is where it gets really exciting. Let's look at the numbers.
The headline number is just staggering, a 30.85 times faster time to first token. Now what that means is the time you wait between hitting enter on your question and seeing the AI start to type its first word.
A 30x speed up there is the difference between an AI that feels instantaneous and one that makes you wait. It's a total game changer. And check out this comparison. The previous best method for speeding this up, something called CEP, gave you about a 2x speed up. Not bad. But REFRAG, even without its cache warmed up, gives you an 8.5x boost. And with caching, which is how it would work in the real world, it's over 16 times faster. This isn't just a little better. It is a monumental leap forward.
Okay. This is the big question, right? The one everyone should be asking. Getting a 30x speedup is incredible, but does it even matter if the answers get dumber? Did they have to sacrifice quality to get all that speed?
And the answer, amazingly, is no. This table shows a metric called perplexity. Just know that for perplexity, a lower score is better. It means the AI is more confident and accurate. And look at that. REFRAG's score is almost identical to the original super slow full context model. It's just as good. So the big takeaway here is they got all of this incredible speed with virtually no loss in accuracy.
So, to put it all together, the old way was brute force. You feed the AI the full text, it processes every single word, and it's slow and super expensive. The new RFRGA way is smart. You feed it compressed summaries, it focuses only on the key ideas, and you get up to a 30x speed boost with no real accuracy loss. It's just better.
Now, this is way more than just a cool academic paper. This is a breakthrough that's going to have some massive real-world implications. So let's talk about why this actually matters to you.
This tech means we are on the verge of way faster, much more responsive search engines and AI assistants. It means chatbots that can actually remember a long, complex conversation without slowing down to a crawl. It means you can have an AI assistant summarize a 100-page PDF for you in seconds, not minutes. It even means the AI works better when the initial document search isn't perfect, because it can afford to look at more documents to find the right answer.
And that really just leaves us with this one big, exciting question. For years, the amount of information an AI could process at one time has been a fundamental limit. Now that brilliant techniques like REFRAG are starting to just completely shatter those limits, what's going to be possible next?